Limited, Chennai, is going to deliver the topic on data visualization using machine learning. Happy to introduce Mr. Vishal. Mr. Vishal completed his Bachelor of Engineering in the field of computer science at the KCG College of Technology in the year 2018 and postgraduate program in data science and engineering from Great Lakes Institute of Management in the year 2019. He is a Cisco cyber security specialist and currently working as a software engineer, Solverminds Solution and Technologies Private Limited. He completed projects in the following domains: web scrapings and sentimental analysis of customer reviews of products in Amazon, loan eligibility prediction system using machine learning techniques, and e-commerce analysis using machine learning techniques. Very happy to have Mr. Vishal for today's session. On behalf of Electronics and Instrumentation Engineering and my own behalf, I welcome him. Now I request Mr. Vishal to take over the session. Please, sir.
Guys, you're safe during this crisis situation. Can I share my screen, sir?
Yeah.
Yeah, sure. Yeah, okay. So I think we'll just start with this. What is the data visualization using Python and basic thing? I saw the recent video regarding the basics taught by another faculty in yesterday's webinar. So it was mainly focused on machine learning and the things which we can do in what to say, how to predict a model and build a model and other things. So apart from machine learning, we can also do data visualization using Python. So that's what we are going to do now. So it's simple, in Python, there are a lot of libraries to build data visualization. Say, for example, we can just plot whatever graph we want, say these graphs you can see. So like that, we can just do it. So basically, Python has around 2 to 3 libraries. So that is the main commonly used libraries which we can use for generating a variety of charts. So that's how the data visualization is going to work. And the main part of doing a data visualization is we have a lot of data, scattered data, and we can also recall it from the last session that there is a unsupervised learning and the supervised. So in the field text of supervised learning, we can go and feel we can know the value of the fields and other things. So it's supervised learning will be field material, but then in terms of unsupervised, we need to in a bag of that red, green, blue balls, we need to sort and build our own model. So during that process, the data visualization will be a much better one. So firstly, we will just address what is data. So data is nothing but what unstructured part, raw information we just collect it from a day-to-day life. For example, Amazon. So if we go and just click the Amazon app and just exit, there will be a lot of data will be generated in the backend. So that is what it will be useful, because no data will be misleading or unuseful. Each and every data has its own kind, and we can easily use it. So for example, if you just open the Amazon app and just close it, in the back end, there will be a lot of parameters will be loaded with data. So for example, we will just go the click, if we click the app, the time will be recorded. So also the page out and the time spent on the app and the location, user ID and other things based on each and every field, the data is being loaded. So this is for a single user, but we can also Amazon is now a popular brand, so lot of people will be logging on the same time, and we just, so there are lots of data will be generated each and every second or even microseconds. So that's how data is widespread, and we need to solve it regarding this. So that's how this data visualization work. So for example, if we need to check whether the how many, like what to say, we can, I have also done one documentation regarding this data visualization. We will just see in the later part. So this is how data works, and that is the format of data. So in simple terms, like what to say, we can say data is a raw fact. So it may be structured, unstructured, and anything, because even a video is a data, because it can give each and every pixelate values and other things. So that's how the data works. And the collection of data and processing and doing a visualization part is somewhat a challenging task, but with the help of machine learning and data visualization, we can achieve it in a quite simpler manner. So see, this is what we just talking about data. So the computing and information plus instructions equal to knowledge, and this will be the basic definition of a data. So there will be also metadata and what they are clubbed of metadata and data. So that's how it works. And this is how data is what is this scattered or extracted in a meaningful manner. So for example, if you go and extract a particular data and the information, knowledge, and understanding, we can split that particular data into multiple parts. So that's how it works. And coming back to the visualization, can anyone tell me like what is visualization, or like what is it? Have anyone used this PowerPoint like for building some basic charts and other things? Hello.
Hello, sir.
Yeah, audible,
Sir,
right?
actually, this is actually in our Zoom, we have only 5 coordinators are there in Zoom. So
Okay.
your session will be directly, it will be linked to the YouTube. So whatever the participants are asking or any other clarification, we need to only transfer to you, sir.
So the people are active, right?
Yes, sir. Just a minute, sir.
Participants can type in the chat box if you know the answer for this question.
I will just recall it. Has anyone did any kind of a simple visualization, like building a pie chart or just a normal bar graph in PowerPoint or other things based on some simple data?
Hello, sir.
Vishal?
Hello,
Vishal, I have an answer from Akshaya Shanmugam. Visualization is expressing the data in terms like graph or flowchart.
Yeah, that's what.
And okay, and you have one more answer from Shoban. Visualization is imagination made by our mind to solve the problem.
Exactly.
And one more answer is graphical representation of data.
Yeah, it's simple as that. So based on the data we have, we can generate a lot of varieties of graphs. So as of now, there are basically line chart, bar chart, and pie chart. These are the things will be used as a normal one, but we can also use a wide variety of charts. So for example, geographical charts. With the help of geographical charts, we can also filtering. So there's a separate tool for this visualization that will be like a Tableau or this one Power BI and other liquid. So these are all you to say the advanced level or so, but we can also use these visualization what we used in this PowerPoint and other things. We can also use this with in Python with the help of data visualization and the libraries available in Python. So this is what we are going to do now. So as you guys said, like visualization or visualization technique of creating images, diagrams, or animations to communicate a message. So it's intuitive. So how to say, when we have a larger data, we just can't able to scroll and view the data, but we can also plot some data. Say for example, if the rise of COVID increases between the area wise. So for example, Chennai and other things, we can easily plot for a graph. Obviously, Chennai is more higher, but still we can also compare with other districts. So that's how these data plays in the form of visualization as of now. So that's what it will be appealing and also easy to understand in the graphs, line charts, and etc. So we will just do a simple what to say visualization part. So I just choose one data set called house price data set. So this data set is very simple and it's also like it will be easily available. So the main objective of this data is to find like if you are going to buy a house, you just have a lot of parameters, right? The square feet and what is it? Square feet, the parameters which include the square feet and other things, the number of bedrooms and other variables. So that based on that, we are just going to build like what a small visualization documentation. So that's how like we can use this machine learning in terms of visualization part. So we just go for this one. So yeah. So I hope everyone can see this. So as I said before, we are going to do this for the house price analysis. So this house price analysis, we just, as I said before, we use this basic libraries. So these pandas and matplotlib and seaborn are the basic libraries which we'll be using in Python for what to say, any data or a data science or machine learning part. We just use these libraries to build a model and other things, and also use for visualization. So as I remember that you just went through like how the machine learning model works and other things. So this is how the code will be for what is a extraction of data from a file, and we just load it in this documentation. So for example, this is the data, so house trained data set, so that we are just going to do, and you can see a variety of columns are available in this data set. So for example, we can see the kitchen average and what is it, the fireplaces and garage type, number of bedrooms total, whether the first floor or other things, and it will be around a wide variety of variables will be available for a particular data. So this will be like what to say 2030 means there will be like what to say, there will be a much column names when compared to handling a larger variety of data. So that's how we just need to sort it out whether these data will be available for the visualization for a perfect manner. For example, if we have 30 to 40 columns, not every 30 to 40 columns will be most important to do a visualization part. So that's how we just need to sort it. So for that, we can use machine learning techniques. We just need to give the scores for each and every column, and you need to extract whether these columns will be much more useful in order to predict the model. So we will just see in the later part. So these are the basic things. So for our example, we just have these much of columns. So you can see utilities and year belt and other things. So it will be like what is a form data, which will be having each and every column. So that's it. And you can also see with the help of this command. So this is the information command. So this will give whether these data set have any null values or not. So these null values are like what to say, if you are filling 1,000 columns of data or 1,000 rows of data, not every column, like what to say, will have at least one or two non-entered numbers. So that we can just see in this graph. So for example, as of now, there are 14,000, sorry, 1,460 entries. So this we can see it, and in Python it will just start from 0 to the n-1. So that's how it works. So that's how it works, and you can see each and every column have any null object or null. So the total amount is 1,460. So we can see this column. So ID obviously it will be like a primary key. So I think people must have like what to say, have any idea about this primary key, or like what to say, default value. Like people have any idea of this ID? Anyone? Yeah, okay. So this ID is a mandatory one. So for example, the serial number will be a ID, and other things will be like for a safe street. So there is a street, obviously house will have a street number and other things. And if you want to see like the null objects, so for example, not every house have a 2-bedroom or a 3-bedroom. So based on this, if anything like what is it, if one house has a 2-bedroom and other one has 3, so the columns will be the same for each and every data, but the data entered in each and every column will be vary. So that's how we can see whether these columns have a null value or not. So we can see. So this alley value as around 91 null values, and other things are completely fine as of now. You can also see half bath or full bath, so bedroom, and the garage cars. So there will be a lot of problem without having a parking space. So that's we can also find with this data. And after just overviewing of this data, we just getting only the first 5 columns of this data. So why first 5 columns of the data means we can just easily see whether these data, what are the data presented in this particular data frames. Actually, in Python, we are handling these kind of data in a form of a data frame. So it will be similar to Excel sheet with entered values. So that's how this will work. And so looking at the number of rows and columns using the shape function. So we can also use this function to find how much size this data has. So for example, if we give the shape, you can see the entries of this 1,460 rows and 81 columns. So as I said before, 81 columns, not 81 columns will lead us to provide a perfect data visualization model. So that's how we need to segregate and analyze which are the key factors which will be using by us in order to provide the visualization in a more effective manner. So that's how we are going to do. And see, for example, this will give us the percentile commands. So for example, a describe option will go for giving the mean, standard deviation, and these values are will be, I will just cover this because this 25% and 50% and 70% will be covered in this part of visualization part. So that will be a helping one. So first we just going to see the histogram of a sale price. So obviously a house will have a sale price. So if we go and see, we can see these peaks will tend like this is a normal bell-shaped curve, and we can see there are a lot of bins created here. So for example, 0 to like 1 lakh or something, and so that based on that, these obtained data. So for example, this 14,060 rows, the data in that 14,060 rows will be plotted within this graph. So this is much easier to understand. So for example, you can see obviously the peak of house price will be around so 10 lakhs to 20 lakhs. So that's how the peak price of the house. So for example, in the particular data set, we are having the house prices ranges between 10,000, 10 lakhs to 20 lakhs as the basic, the entered value are higher when compared to other values. And if we see this normal shaped curve, this is actually a skewness. So skewness will be like the extreme values. So we can just see this. So this will be the skewness. So this data is spreaded upon about 80 lakhs. So that will be the maximum price. And you can see in this 80 part also there will be a not much type of houses are available in this segment, but the main type of houses available in this 10 to 20 lakhs segment. So that's how we can just find whether these data that's how we need to plot for this particular one. And after that, we can go for this skewness and kurtosis of sales price. These are all the normal because these include some mathematical calculations behind the scenes. But for visualization part, we just need to just know what is this peak and how widespread this data goes. So also we can use some bivariate analysis. So bivariate means we can just compare both columns. So for example, we are going to compare the sale price of overall square. So that's how if we need to go and check whether these particular sale price of a house is equal to what when compared to the overall square of this that square meter. So I am not a typical a civil engineer or not, but I think most probably people might know what are the basic terms of the things we just going to add in this data set. So that's how we are going to do. So we're just using two set of columns to compare for this. So this is a box plot. So this box plot will give the perfect mean, median, and variance. So as I said, there will be a 25%, 50, and 75%, right? So this will cover the 25, 50, and this will be the extreme 75. So that will box plot will works, and there are a lot of calculations because this machine learning is based typically advanced and documentation. Literally, it will be text with mathematical formulas and other things. So it will be Newton's define the Coulomb's law and other things, right? As you guys are E and I, so probably you might have read a lot of computations regarding this deriving an equation. So like that only these machine learning algorithms will also work. So it will be lots of algorithms will be present there. So this will be a basic one, and this will help you to find the mean value, the median value, and also these will be called as outliers. So for example, if a data the mean is around 50 and the highest values for example if we have a data set for 10 numbers, so for example 1, 2, 3, 4, 5, 6 and 100, 250 like that. So this 1, 2, 3, 4, 5 will be lying in this part, and the 100, 200 because these are all the extreme values which will be available for this data set, right? Because 1, 2, 3 will be a continuum number, or not even 1, 2, 3. We take like 1, 10, 20, 30, and directly you are going to jump for this 100, 200 and other things. So it will be too much variation in the data occurs. So that's how we can find whether how this data is splitted and other things. And the next one will be the same. Because with the help of box plot, we can find a variety of insights from this one. See, for example, we are going to give this year built with the sale price. So for example, so there will be also the calculation of age of the house, right? So for example, if we build a house at 2020 or 2019, it will be having a much more pricier than the old ones. So the strengthness of the building and other things will come as a part of this. So as I'm also telling, like I won't be like much into this civil field, but these are the factors will be we are going to take. And before we are just going to jumping into data, we just need to understand the value of the columns. So for example, if this year built is a variable, we just need to know the definition of this variable. So for example, the sale price means the price of the house and other things. So each and every column or label will have a perfect definition. So that's how it will work, and it will be much more easier in order to understand it. So these are all the 2D types of plots we are using in Python, and 3D parts we can also use with the help of a plotly. So that plotly will be as again it will be a library. So Python is full of library. If you just call the library and put some this code like compare between sale price and year built, it will just give you the type of graph you can do it. So also in other visualization tool, it will be like Tableau and other things. So Tableau, we can also do the same, but it will be more interactive and other things. But as of now, it's since Python is an open source, we can just easily learn everything, and also we can give some additional values, say setting the histogram peak and the variations and other things. We can also add a new column based on, for example, setting the bins is a much more challenging task for a histogram. For example, we need to find the range, house price range between two between a data set means also the 1 to 5 will be one category, 5 to 10, and like that we can just do it in Python. So that's how this works. And the next part will be this this correlation matrix is the must what to say will be much more useful when you are going to build a machine learning model or using some visualization part. So as I said before, we need to check the variable importance. So the column value should be incorrelated, what to say, the correlation between one column and other column should be high. In order to, we just need, in order like what to say, we can easily connect the dots. What to say, if the area location versus the sale price, obviously there will be high correlation, because if you're getting a house in Adyar or Srinagar, it will be costing much higher than the ones we just use to get a house in this Chengalpet or other things. So not so like that we can find the value how the data is positively correlated or negatively correlated. So this will just tell us the weakness. So this what is it? This color will be a positively correlated, and this will be a negative one. So that's how it works. So this will be also very useful in order to find the visualization, like what to say, how these columns are incorporating with each other. So for example, if you have a car, so if you just build based on the variables or labels. So for example, if the more the weight the car, you just get the lesser mileage. So that's how we can find whether the correlation is high or low. So that's a simple one for this correlation graph. And this correlation graph looks so clumsy because we just took each and every 80 variables and just plotted the graph. So that's how this works. And next one will be this is a normal visualization part. So in Python, as I said before, just call a normal library and use this command. Say for example, this SNS is a seaborn library. We are going to see much more detail in later. So if we call the seaborn SNS and do a pair plot, it will give each and every plot available for this particular data set. So for example, this one is an histogram, this one is a scatter plot, this scatter plot. So that's how, like what we saw in the correlation matrix, it will just plot based on the correlation matrix, like the big pair plot. So it will give this graph with that graph, and that will be much more easier in order to visualize, like what to say, we can just compare between two other things. So that's how this works. And you can also get the visualization part in a text value also. See, lot of negative correlation are happening between each and everything. So these are the things that mainly will be what to say focused on the visualization part. So we'll just also use this. So this pandas we are going to see. We have seen just these pandas, seaborn, and what to say, matplotlib are all the libraries which are available in Python. So if with the help of pandas, we can build a series or data frame and other things. So I think we need extra. I think we need extra set of additional hours in order to learn this, but these are all simple ones. So with the help of pandas, we can build a data frame and do some computations. For example, finding the mean, median, mode, and adding the columns and finding the average and other things. So with the help of pandas, we can do each and everything. And with the help of matplotlib, we are doing the things right, the correlation matrix and other things. We are just obtaining from this matplot library. And this Python is full and full of library based one. So I think I'm just hurrying, but does anyone have any doubt regarding this? Because this is how a proper machine learning, or the way we just taking the data, structuring it, and going for this visualization part. And after that, we are just going for this prediction. So anyone have any doubt about this?
Yeah, Vishal, we have one question here.
Yeah.
This is, can you show how to get the data sets?
Yeah. Okay. So I'll just call you. Yeah, 1 second. I'll just load the data. think you guys can see my screen. So this will be the data set. We are just going to call it. So just copy the part of the data set. So with help of shift plus right click, it will just get you to this one. Okay. I just created a new document for someone asked, right? Someone asked right how to load a data set. So it's a simple one. Just call that libraries. Say for example, the basic library which we need for the calling the data set or do some computations is this pandas. So with the help of pandas, we are just going to create it. So that's how we are just going to do it now. So for example, I just name this variable as df equal to. So we just call this pandas. So we just set a alias name as PD, pandas as PD, and read underscore CSV with which will be the keyword in order to call a data set that is in a CSV format. So that's how. Okay. So that's how we just need to load. So the data set has been completely loaded. If we just recall it, see, we can see the values of the data set. So this is how our data set is need to obtained in this type of a document. This is a Jupyter notebook which will be widely used for data science and machine learning things. So with this help of this application, we can just build a lot of codes and do some documentation process, because there are also a lot of complete developer packages like developer IDEs like say PyCharm and Visual Code, but this Anaconda Navigator will be a much better option if you are going to do some data analysis and other things. So if you guys are really interested in doing some data analysis and other things, you just Google this one. So this will be this Kaggle. I hope everyone can see. So this is the Kaggle. This will be the machine learning repository for each and every data science enthusiast or everyone. And you can find a wide range of variety of data is available in this site. So we can just go to the site and see this coronavirus and other things. A lot of data are available in this site. We just extract it and do some analysis. So that's how this completely works. So that's how we just going to load the data set in this Jupyter notebook. So any other questions? So I think we just
as of now, no more questions.
Yeah, okay. I will just
they haven't. Yeah, you can carry on.
Yeah. Okay. So see, I said like we can also do some bar plots, right, with the help of this. So these are all a lot, complex codes which I just use for the data search. Also, I just took it from this Kaggle site. So you can find every type of data set, even PUBG data set and Zomato food reviews and other things, Amazon, any data, you can just get it from there. And also there is a site called data.gov. These will give some government data, for example, the population and some census reports and other things. So that's how this works. And with the help of this particular graph, we can infer like the garage area is higher, and see, we can see the garage cars is higher. That's how this works. And the main part of visualization is not every graph is perfect for this. So in order to, we need to modify the data in order to build a perfect visualization part. So that's how we are going to do some data transformations. And these are all some advanced topics in this machine learning part, because I've seen the last video where you guys posted about the supervised learning and unsupervised learning. So in the supervised learning, we just used linear regression model. So that is a basic type of regression model which will be used for continuous data. So for example, continuous data in the sense, this we are going to predict, right? Continuous data. House price is a continuous data because the price may vary by time. For example, and it will also go like 0.25 to 0.3 like that. So that we just take this as a regression model, and the supervised algorithm is also has another type called classification models. So classification models which we need to know, like for example, a person will buy this product or not. Like for example, it will rain or not. So based on each and every parameter which we obtained in the weather report, so we can just feed it in the machine learning model and just do some analysis, and we can predict whether today it will rain or not. So these yes or no questions will be based on the classification models, and unsupervised and on other things all will be a separate one. So that's how these works. So before applying a model, we just need to transform the data. So that's how we are going to transform the data. So for example, we just saw a particular type of histogram graph in the previous slide, right? So that's how I just improved this histogram. See, for example, the normality of this curve is this one, it's a perfectly one, and this is the previous update one. So when we compare the both, we just applied some data normalization techniques in order to fit the graph and evaluate the data. So that's how these transformations and work. And this is a probability plot. You can see these are all the linear data which we passed in this graph. So that's how this you can also find some exchange values and other things. So that's how these things will be validating one. So these so as I said before, we can also apply some log transformation and probability plot and histogram and normal plot. We can apply each and every plot in order to find the skewness and the data normalization and visualization part and other things. So that's how this works. And when coming back to the slide, I think we just covered this matplotlib. So matplotlib is nothing but than the library which has line chart, bar chart, and other things. So that's how this works. And matplotlib is a 2D plotting library which produces publications, quality figures in a variety of hard copy formats and interactive environments. So these visualization we do in Python will be mainly focused on 2D graphs. The basic libraries which we are using. If we go for this plotly and other advanced level of graphs, we can use as a 3D type of plotting, but we don't what to say, if you go into use in a documentation part with the 3D graph, it won't be much what is the interesting and interacting. So that's how we just move these next level of data visualization using Tableau or any data visualization tool. We can use this Microsoft Excel as a data visualization tool. So that's how we just going to move, and we just plotting each and every graphs, and that's how this works. So this is a recent example. I just saw this. So let's take an example. Suppose I have USB data feed coming in from a device. For attention, now I want to plot or visualize the readings. So how will I do? So we can use this matplotlib and other things with the libraries, and this will be like what to say. So anyone can just explain like any procedure to do this. So it will be like what to say, just a gist of like any approach and how to sort this visualization part. So anyone? Okay. So it's a simple one. I'll just do another example and just tell you. Coming back to the house price prediction, these are all the comparison plots we are just used, and bivariate analysis and simple one. So this one, as I said before, we can use some scatter plots, and you can see pale yellowish histogram in the upper part, right? So this will be going to those. For example, we can use 2 bar graphs for doing data visualization, or using a comparison between a bar chart and a pie chart based on the data we are going to select. So I used a lot frontage and square dot area. So I just also specified the colors of this visualization. So we can also specify the colors, the type of plot we have. So here I used a joint plot. So it will just compare these things. So that's how this works. And yeah, based on the, you can see the mass, and area. So you can see a lot of data scattered, and some data will be like in a ordered manner. So that's how these data visualization will help you a lot in order to find which are the scattered data. So if these scattered part will be like, what to say, in extreme values, we can also ignore it, or we can also like transform it into normal variables and just do it. So that's how we are going to do some data visualization part. And these are all the variety of charts will be available. So this is a stick chart. So this will be like more interactive when we plot this as a 3D chart. So if we just click this node, it will just it will do some filter operations and so other things. So that's how these works. And based on like a simple graph, you can just see whether the value of the data which is present in the data set. So for example, the amount of first floor area helps in the sales price in prediction. So if I just predict this graph, plot this graph. So sale price with the first floor, and you can see the sale price in dollars. So the most of the data, like what is it, most of the data lies in this area. So 2.50, and it will be around, what is it, square feet. So we can see 1,000 square feet as a lot of thing, and says this is an outlier. So that's how we just plot and find whether these variables are completely useful and what to say, useful for this prediction and data. And also we can create a new variables, as I said before, with the help of pandas, and use some histograms. So this I just created for this sales price per square feet. So that's how this data visualization in machine learning works. If you need to take to the next level, we can also use Tableau. So that will be somewhat interesting one, because we can also use some geographical plots and some filter options. It will be like much more similar to Excel one. So this is what we can do in Python. So I think I just covered everything which I need to talk, and I also said about like how these libraries, Seaborn, Matplotlib, and pandas will be working. So that's it. So yeah, any other questions, or like you have any idea of how I can improve the plot? Because I know I just did some basic plots. So any idea, just I can just improve my plots based on this. So that's it. Yeah. Any questions, you can ask me. Any other questions?
I have a question here.
Yeah.
Are data science and data visualization different from each other?
Good question, because data science is one, what is a wider spectrum of things. For example, if you are a data scientist, you need to work on each and everything. For example, you're going to do on machine learning models, build some TensorFlow, the facial recognition, artificial intelligence, each and everything will come under a picture of data science. And data visualization is a part of data science, not it is a separate one. So, for example, if in the whole big circle, if the circle is a data science, these things, machine learning, artificial intelligence, data visualization, and the big data will be inside the circle. So that's how the thing works.
We have one more question here. Vishal. Can you please tell us any other websites for getting data sets?
Yeah, okay. Firstly, we can go and get the data from kaggle.com. So it will have a wider variety of data sets, each and every category, for example, food or movies and shopping, healthcare, Medicare, anything we can get. And other sites which we can approach, for example, we can go for this analytics Vidya. So that is also a portal for analytics, and we can just get the data from that and just use it. So they also have some sample data, and apart from this, we can also extract the data from live Amazon. For example, if you're going to purchase a product, we can just extract the data from the site and say whether this particular product has a true value of comments or ratings. For example, if a particular product is rated as 3-star or 4-star, based on, but the comments are like what to say, it shows like it is the product is worst, or like it will have some comments. So if we start to analyze the comments, we can just find whether this product is worthy one or not. So that's how we can just build our own data set.
Hope, dear participant, hope your question is answered. And we have one more question here.
Yeah.
How can we integrate or do any changes inside the classifier?
Okay.
How can we? Shall I repeat once?
Yeah,
how can we integrate or do any changes inside the classifier?
So the classifier, they are going to build a model, or okay, I just got it. For example, if you are going to build a classification model, and there are some metrics which we follow in order to evaluate the process. These are all the statistic ones. So for example, we need to find the accuracy part. Then we need to plot the true positive rate and false positive rate. So and other things. So these things will be the major one which we can improve the model accuracy, or all, based on that we can also alter the data in order to improve the model. So that's how this works. Any other questions?
Hope the participant, your question is answered. Participants, please type in the chat box if you have any further queries, doubts to be clarified.
The comments are like what to say, it shows like it is the product is first, or like it will have some comment. So if we start to analyze the comments, we can just find whether product is worthy one or not. So that's how we can just build our own data set.
Dear participant, hope your question is answered. And we have one more question here.
Yeah.
How can we integrate or do any changes inside the classifier? How can we? Shall I repeat once?
how can we integrate or do any changes inside the classifier?
Okay, classifier, they're going to build a model or okay, I just got it. So for example, if you're going to build a classification. I hope the questions are being answered. Huh?
Okay, let's wind up the today's session. I thank Vishal for answering the queries and clearing the doubts of the participants. Now I request our FDP coordinator Padmavati ma'am to propose vote of thanks.
Thank you, ma'am. On behalf of good evening to all. On behalf of organizing team, participants, on my own behalf, I would like to thank our today's speaker, Mr. Vishal from Solverminds Technology Solutions India Limited, for taking his precious time out and consulting to be the chief guest for this today's session. Thank you, sir, for your informative and highly knowledge sharing session. Thank you once again. And I would like to thank our management team, principal sir, and respected HOD sir for providing the constant support for organizing this kind of event. Last but not least, I thank you all the participants for showing their interest in this program. And participants, please be noted, your attendance and feedback link, everything will be shared in your WhatsApp group. Thank you, participants. Thank you, sir. Thank you, ma'am. Thank you.
Vishal, thank you so much for sharing technical information on machine learning with us. Wonderful presentation. Thanks for spending your valuable time with us, Vishal. Thank you.
Yeah, thank you, sir.
Okay.
Okay, sir. Thank you, Vishal. Thank you for sparing your valuable time with us. Once again, I'll thank the participants who actively participated, and we appreciate your feedback too. Tomorrow we'll have the day 4 session, which is on building and energy management systems by Vinay Varne, Grundfos Pumps India Limited from New Delhi. Hope we'll meet tomorrow, same time, 3:30. Thank you all. Have a nice day. Stay home, stay safe.
Ma'am, shall we end the session?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Yeah.